In today's world, applications are required to be highly responsive and always online. To achieve low latency and high availability, instances of these applications need to be deployed in data centers that are close to their users. For example, if you have your users globally, or let's say in US and in India. So of course, if your data center is in US, Indian people will find a little latency. So what we prefer, or what application prefer, that users can get the data from their nearby data centers. And applications need to respond in real time to large changes in usage at peak hours, store every increasing volumes of data, and make this data available to users in milliseconds. To accomplish all these tasks, Azure provides us with an improvised version of Document DB, which is globally distributed multi-model database service known as Cosmos DB. All right. Hello, everyone. My name is Arun, and today we are going to talk about Cosmos DB. So while we dig it further, let's try to make it little presentable so that we can actually summarize at the end. So why we need, or what task Cosmos DB fulfills, is that we just talk about. Applications which are required highly responsive and always online, low latency and high availability in various geographic regions, okay, and large changes can be synced in instantly, so that consistency would become good. So this is something which Cosmos DB provide you, and we use for such an applications. Okay, now be with me. We'll talk about few key benefits, and then we'll do the demonstration, and all the points will fall in place and you would make sense out of this. Okay, so we understand why we need the Cosmos DB for these kind of applications. I give an example of applications for US users and the India users. We are talking about the DB perspective. Okay, don't get confused with the CDN. So let's talk about few benefits, and then we'll try to understand, we'll try to create this in the Azure portal, and you would make all the sense out of it. So the very first key benefit is globally distributed. Or if I have to define Cosmos DB, I told you it's globally distributed multi-model database service. And with a click of a button, Cosmos DB enables you to elastically and independently scale throughput and storage across any number of Azure regions worldwide. Hope now this is clear why it is not CDN, but it is Cosmos DB. So it's globally distributed. Cosmos DB enables you to build highly responsive and highly available applications worldwide. Cosmos DB transparently replicates your data wherever your users are, so your users can interact with a replica of the data that is closest to them. If we talk about the example that we did, US and India, in that scenario, you can easily choose any region and make it a read replica or write replica. Of course, cost is involved, but that can be done with a click. I'll show you. Okay, now this is highly available and it provides 99.999% of availability. Okay, for both reads and writes replica of databases and the actual databases. Okay, and you can also use, or you can do failover, regional failover for your Cosmos account programmatically. This capability helps you to ensure that the application is designed to failover in the case of regional disaster. So you would have the capability of regional failover. You can decide it. You can do it in case of disaster. And keeping database schema and indexes in sync with an application's schema is especially painful. We all know that. Especially for globally distributed apps. With Cosmos DB, you do not need to deal with schema or index management. The database engine is fully schema agnostic since no schema and index management is required. Okay, so it saves a lot of admin overhead and index management. Okay, taken care by DB engine. All right, let's go ahead, and it guarantees a low latency at 99th percentile worldwide. Using Cosmos DB, you can build highly responsive planet scale application. That's the word. It's not a simple scale, it's like a planet scale at a big level and highly responsive. Okay, let's go ahead and let's see what else. Well, it is also not like the usual document DBs or other resources that we have available in the market, maybe in other public clouds. They usually provide two kind of consistency, that is eventual and strong, but it provides you 5 level of consistency, and you can choose as per the requirement of your application. Okay, you no longer have to make extreme trade-offs between consistency, availability, latency, and throughput. Cosmos DB multi-master replication protocol is carefully designed to offer you various, in particular 5 well-defined consistency. We'll talk about it, don't worry, and you will understand what is this. And it will help you to choose the right level of consistency in case you have encountered such a situation. And this Cosmos DB is already being used by Azure in various well-renowned applications, so it is by default secure and enterprise ready. And the applications that it has been used in is Skype, Xbox, Office 365, Azure itself, and many others. So by default, it is secure and enterprise ready. So, well, this is a little overview about the Cosmos DB, and a lot of things we will understand when we will create it from the portal. Okay. Right. Let me go to the portal and we'll type here Cosmos DB. Click here. Now add. Okay. So you need to select the resource group. I've selected mine. give it account name that would be unique, and there would be a URL to access it. Let's say my Cosmos DB demo test. These are the APIs that you can utilize, and as I said, it's a multi API that you can use. You can go for any of these to fetch the database. Okay, it is one of the great features that this provides. Let's select the core SQL for us right now, but you can go for any of these that you are good with, of course. Now you need to select the location. Account type is nothing new. Here are the two other things: geo redundancy that we talked about, and the multi-region rights. So from here you can enable both. You can choose multiple right region, or you can choose geo redundancy, multiple or paired region, and multiple secondary region. Multiple secondary region you can choose later. For now it would be geo redundant because I have enabled it. That means it would create, send, or keep the data in the paired region as well. Okay, review and create, we can do that. It takes a lot of time, so I have created already for you guys. This is our my Cosmos demo test. Right here you can see nothing is there, it's absolutely empty. All right, once you hit it, it will come to this page. Go to the resource, you click on that, you'll come here. Okay, now let's go to Data Explorer. All right, and here you will see the structure. The structure is we have database, then we have container, and then we have the items inside that. Okay, so I'll create the I'm sorry, container. Now, once I create the container, we need to create the database, then container. We need to give the partition key for the database, and these are the throughput. We'll check the default, and we'll be good to go. So let me give the container name as database name as Cosmos. That's okay. Container ID, let me give it a container. Partition key, let me give it ID. All right, let it be 400. Click OK. Now it is creating right now, and as I said, the structure is always like database, collection, and document. Okay, and this would be inside a container. So inside a container, what we created a database named Cosmos. Inside the Cosmos, we have containers. Inside the container, we would have items. That is your document. It would be in JSON format. If you click on item, it is nothing right now because we just created it. It's absolutely empty. But you can put it some data just to check. Let me click new item. It will give you JSON template. Let's give the ID 1001, comma. You can give anything else. Let's give it a name, colon. Give it some name. Let's captain, comma, enter. Give it a location. India. You can copy it if you want to use it in another item, and you can save it. Now this item is saved as a document. You can create one more, paste it, change the name, put it anything else, let's say major, and you can save it. So now you have your document with you. Yes, we need to change the ID because ID has already been there. Okay, now we got two documents here. Similarly, you can create more, save it, change the ID. I'm doing it manually, but usually it would be done by the applications. Okay, Just to understand how it is working, let me give it a name, Sergeant. Save. Okay. You can create many more databases or containers inside the same database. Okay. So if I click here, I can click one more container. You can see we have all the information here. I can fetch the example from MS Doc that can help us to understand how it is happening. And let's do this. Give it a name and perform the example. So I can give the container ID as families. I can give partition ID as category, or I can use again, let's say last name. Okay, and click OK. So what we did, we created one more inside Cosmos. Okay, inside the database that we have created, when we got two containers. Inside the family container, we have nothing. We got three a document in the first container. We can create more here as per the information available here. I'm following a Microsoft Doc here just to give this example. The other one I did by myself. I need to show you the query as well. So we'll try the query in both the containers. So we got two more here. Now, here is the query, the SQL query. In the same we are working. Now select star from, we can choose families, right? Because we had the families as container, families, we call it as F, and we can do where F dot ID is equal to, we can paste the Andreas family. This is from the document. So it will give me the information about the Andreas document. Maybe I have done something wrong with the okay, it shouldn't be like that, or maybe I have not selected the right one. As I said, this is whenever you encounter an error, it is always good. It is good for the learning purpose, right? Yes. So let's see, where are we stuck, or what is the issue? So what we did select star from families. We got the families here. We are noting it as F, where okay. I don't think it make issue because it is oh, it did. It should be small. It's case sensitive when we denote it, else not. So this is what we got from Andrew family. This is what we decided. If we go to the container and try to run the query, we can see, just run it. It will give us the information of our container, all the three documents you can see. All right. So that's how it can be done. Now, this is not, this is just the feel of Cosmos DB. We talked about it, what Cosmos DB is. We talked about how we created, what all information is needed. That's how the document works, the structure. Now, let's see these two important things. First of all, data replication. See, as I said, we selected geo redundant. That's why it is in the paired region, and it's read enabled and write enabled, both of them, right? You can choose from here as a secondary read region as well. You click here, add region, for read, write, and availability zone, and you can add more region here, right? You can do that. Okay, just like this, you'll add your more regions, and your users would not feel latency or performance issue. You can keep on selecting and adding. I have not saved anything because it all involves cost, but this is what I meant. All right, your users from US can get easily, but people from Australia or India would not able to get or fetch the data so easily. There would be a latency performance issue. But if you select that as a secondary region or a read replica, it would help you drastically. And what we mentioned at the beginning, that would be the case, that would be the use case, that highly responsive is the word. Okay, cool. So we don't need all that, so I have deleted. Now this is what the Five9 networks, we all know about it. We have same thing in the storage account and other PaaS services. Now these are the 5 consistency that we talked about. It is not only about strong and eventual, and if we need to understand this, we need to talk about simple thing, very simple thing. Strong consistency, that means we are focusing on consistency. Okay, I need to create a chart here that would help you to understand. It's very simple, just stay with me and you will understand what I'm trying to do. Okay, and there is one more like this, and you will understand all that in a minute. Okay, now we have consistency here, and we have performance here. Okay, and how this works, it would be in such a manner. In a single go, I'll try to hit it. It would be like if we are going from strong to bounded to session to prefix to eventual. Okay. These are the 5 consistency that we have seen here: strong, bounded, staleness, session, consistent, prefix, and eventual. Okay, so and if you need, so you can see the, all right, I need to create the chart in such a way that it could be okay, which one should I use? This one, will that help? Okay. I need to create it in such, all right. No. Okay, no problem. We'll keep it this way. If it is strong consistency, that means you have to compromise on the performance. Okay, so strong means high consistent, but performance is less. Eventual means it would be less consistent but highly performant. Okay, Or let's see if I have something else to explain it in a better way. Hmm. So, for example, you have your application in US, and you have your people in US and in India and the region which is so far away from US. All right. So, if something changes in US, it takes a minute or two to reach to the other regions, right? The regions which are far away. Now, if it is strongly consistent, okay, if it is strongly consistent, so we may have a latency and performance issue, but the data would be same or highly consistent in this particular option. So what exactly happened here? Until sync done to all read replica or write replica, uh, read replica and primary get the confirmation, you know, all DB would have show the same data, means all data would show same data, and sync and confirmation would decide what data would show. If it is not confusing, let me show you. Let me try to explain a little bit. For example, we have some data here. We have this data in US, and we have some replica in APAC region. Okay, and it takes at least 2 minutes or 2 to 3 minutes to sync in, right? Okay, now it will keep showing the same data until it gets all the confirmation from all the regions. Maybe APAC region we have, maybe we have EMEA region, or one more region as a secondary, any of the Azure region, right? So these are the far away uh, replicas, read replicas, until these all would send the confirmation like we are good, we have the new data. It will keep on showing the old data to everyone. So it is highly consistent. That is the strong, and it's exactly the opposite of eventual, right? In eventual, it would be old data here, but would be highly performant. Okay, while it gets sync in 2 or 3 minutes. So that would be the eventual consistent. Now, in between these two, we have bounded, session, and prefix. Okay, so bounded staleness is like you provide some time, like 2 hours, and all data would show the same data till 2 hours. Until 2 hours, the sync will keep on happening, and once the timeline is there, it will start showing the same data whatever sync is done. That kind of thing. So it means if you do bounded staleness is 0 hour, then it means it's a strong consistent. It will keep on showing, right? Okay. All right. If we talk about session, that means a particular session. And remember, if you see and check the graph, we have performance this side, we consistency this side, and this is exactly in between. So one who commit sees the data. Okay, so he would have the latest information, but it takes time to replicate to others. Okay, and we have prefix, in which it goes in an order. All right, it captures the sequence and sync in the sequence, and on the replicas it would come under an order. So that would be the consistent prefix. So these are few uh, consistency that we need to take care when we choose default consistency. Right here you can see, you can select this you need to provide the timeline that I was talking about. This is the consistent prefix and this is the eventual. Now I know it was not that explanatory, but if we go and read about it a little bit, it will all start making sense. So if I click on eventual, it says is the weakest form of consistency, as I said, because you will get data then and there, but if something is changing on the read, on the write replica, it will take time to come to you. And this is the option where client may get the values which are older than the ones it had seen before over time. In prefix, it guarantees that read never see out of order writes. It maintains the order. In session, mostly widely used consistency level both for single region as well as globally distributed applications. It is the one where it shows recent data for the one who commits. Here you define the timeline to sync or keep syncing and show the same data at that particular timeline. Okay, this is all that. So this is about the Cosmos DB. It's not that small, of course. It is a huge topic that you need to dig around if you want to use it, if you're planning to use it, if there are the projects running in your environment or maybe about to come. But this is a kickstart for you guys. Thank you. Thanks for watching. Hope this is informative and you have a good day.